Stop the noise. If you're lost in the data analytic mumbo jumbo that your colleagues are throwing at you, or if you're just starting out without any relevant degree or technical background and you feel overwhelmed, or you just heard that data analytic is the fast-growing field and you are curious about it in general, you're in the right place. I've been there. I've spent years researching, reading through technical books and blogs, watching dozens of YouTube videos, trying to find the right path for me. However, a lot that I wanted to know was explained in a very technical way, using extremely technical words, and I have to admit, it did turn me off, big time. And I wish someone has shown me a more constructive and easier way to understand method that I can immediately apply in my day-to-day job. So in this video, I want to do just that. I will give you my personal data analytic roadmap. It is very practical and it will help you to quickly understand the fundamental of data analytics. And the great thing is, it's applicable for all levels of expertise. The topics for today's videos are what data analytics is and the role of data analytics in the modern business world. The data analytic process, basically what you will be doing on the day-to-day job. The data analytic tools that will help you to perform the task. We will go from basic to more advanced tools. And finally, we will go over some essential skills that will help you to achieve a successful career. So watch until the end, it will be worth it. Hello everyone, my name is Lynn. For those of you who don't know me, I'm a data analyst and automation expert with experience in banking and logistic industry. And welcome to my channel, where I share my passion in data analytics, productivity tips and tricks that help you to level up your skill and get the promotion you always wanted. Before we start, please smash the like button to help me with the YouTube algorithm. This way you will be helping me to reach out to more people who might find these videos useful. And don't forget to subscribe to my channel for more data adventure coming in your way. If you like my content and want to support the channel, you're welcome to buy me a coffee. I'll leave the link in the description below, and thank you very much for doing so. There's also a timeline in the description box that will help you to navigate through all the sections of the videos. So please feel free to pause, rewind the videos when needed. Ready to level up your data analytic game? Let's dive into it. Data analytics is the tool that helps companies decode information and data overload. In simple words, data analytics is the process of transforming raw data into actionable insight which benefits decision making. For example, data analytics is used for sales predictions by analyzing the past data and forecasting future sales. It can also be used to measure marketing campaign effectiveness, to optimize strategy for better customer engagement. In supply chain, it is used to optimize processes, reduce costs, and improving overall efficiency in production and distributions. In finance, data analytics is commonly used to predict financial trend, investment decision, and overall financial planning. Data analytics is also used in identifying unusual patterns in financial transactions to prevent fraud. As you can see, data analytics transforms raw data into actionable insight across various domains. In essence, data analytics is the secret weapon for companies aiming not just to survive, but to thrive in today's data-driven landscape. How does data analytics is done in practice? Personally, I usually follow 6 main steps. We will go through all of the steps, and each time we will ask ourselves 3 questions. What is it? Why is it important? And how to do it. Data collections is the initial step in the data analytic journey. It involves gathering information from various sources to use for analysis. Data collection is one of the most critical steps because it is the foundation for your entire analytic process. It's not just about collecting the data for the sake of it. It's about strategically choosing the right data to address specific questions and objectives. Without a robust data collection process, subsequent analysis may lack the depth needed for meaningful conclusion. So how do we execute data collections in practice? First, you will need to work with business stakeholders to clearly outline your analytic goals. What question do you want answered? What insight are you seeking? This will guide your data collection strategy and later on the analysis on the right path. Secondly, you need to identify the relevant data sources that align with your objectives. If you work for a big corporations, there's a good chance that they've already have an internal data warehouse system where you can connect and extract the data directly. The common data warehouse are Oracle, SQL Server, Cognos, SAP. You might also receive data sent manually to you in the form of an Excel file, a text file, a PDF document, or even picture. Of course, there will be time that data is not available eternally, and you must seek out for external sources. For example, you might collect data from your customer through a survey or from an analytics service like Google Analytics or Salesforce. You can also buy market intelligence data from a consultancy company. Do stay ethical and compliant with regulation, especially when dealing with sensitive data. Ensure that your data collection practice respects privacy and comply with the relevant laws and policy. Data transformation is the process of cleaning and structured raw data into a proper dataset, making it suitable for analysis. Raw data is often imperfect, contains errors, duplicate, or missing values. Without proper transformation, the presence of inconsistency and inaccuracy in the data can lead to flawed insight. Data transformation ensures that the data is in its best form, setting the stage for accurate and meaningful analysis. Data transformation includes tasks like data cleaning to identify and address errors, outliers, duplicate, or missing value. Next, we have tasks like organizing data, which involve shaping the data to fit the analytical models and tools that you plan to use. And finally, a very important transformation task, that is changing data type. Raw data may come in different types like text, number, date, or time, and classifying the correct data help us to understand data and make the correct calculation in the later stage. Do take into account the size of your dataset, as this will help you to decide which tool or application is best used to handle the transformation process. I'll cover more information on which tool and application you can use later in this video. Data modeling. Think of it as an architect creating a detailed plan that shows where each room will be and how they are connected to each other. So, data modeling is the process of planning out how your data will be structured, organized, and connected. Data modeling is crucial because it's visually structured and clarifies data relationships. A robust data model enhances the accuracy and efficiency of data analysis process. It helps you to optimize the speed of your calculation, quickly identify the information you need. When there is a problem, you can quickly identify where it arises and fix the error. By creating a data model, you are essentially building a framework for your analysis, making it easier to derive insight and predictions. Data modeling can be as simple or as complex as you want it. In fact, it might take years to truly master it. But for now, let's focus only on the most commonly used data model in practice. The first one is tabular model, where you use only one table in your model. It is simply the proper data table, which contains all the information that you want to analyze. Chances are that without even notice, you've already built this type of model before. especially if you're an Excel user. So no further introduction needed here. The second one is dimensional model, which is a little bit more advanced. This is where multiple tables are used at the same time. For dimensional model, you have to spend some time to define the purpose of each table and the relationship between them. Typically, you'll have your dimension tables which store descriptive information that's linked to the business, for example, product information or customer information. Then you have the facts tables, which stores quantitative numerical information like sales, quantity sold, profit, etc. When you connect dimension and fact tables together, a star schema or a snowflake schema data model is formed. If you find these terms and concepts seem hard to digest right now, don't worry. I promise to cover this type of data model much more in details with example in future videos. Stay tuned for more exciting content coming in your way. Data analysis is the heart of the entire process. This is where the magic of converting data, number, into information happens. Data analysis is like peeling back the layers of information to discover hidden insight within the data. The insights drawn from data analysis is used to help business making informed decisions. Without the proper analysis, data remains a collection of numbers without narrative or actionable direction. This stage is the bridge between data and strategic decision making. Before jumping straight to the number, it is good to revisit and align the objectives with stakeholders to ensure that the analysis is on the right track. Again, clearly outline what questions are you seeking to answer, what insight are you hoping to gain. Define a clear end goals that will guide your analysis. With a clear objective set, now you can dive into the data. You can use techniques ranging from basics like filter, sorting, aggregate data to more advanced ones like standard deviation, descriptive statistic, or even machine learning. Remember, the goal is to reveal the secret behind the number, finding patterns, and get insights. Data visualization is the art of presenting data in visual formats, such as graphs and charts, to translate complex information into easily understand visual, enabling user to grasp the insight at a glance. Good visualization not only show your findings, but also help you quickly spot trend and outlier in the data. And using the right visual make it easy for decision maker to understand and use the insight. Data visualization is not about making your chart look fancy. It's about choosing the right visual to effectively present your findings. There are three key elements that will help you to choose the right visual. First is data type, because different charts work best for certain data types. Second is the type of the message you want to communicate. And finally, the audience you want to target, because different audience groups would require different approach in the way you present your data. You want your audience to get it from a first glance, so next to choosing the right chart, you would need to use a clear title, labels, and legends to effectively get your message across. I cover this step much more in details in the videos here. Please feel free to check it out. If data visualization is the art of crafting individual data pictures, data storytelling is the craft of arranging these pictures into an interactive data gallery. In other words, a dashboard that tells a compelling and coherent story. Why is it important? While data analysis provides the insight, storytelling is what makes those insights impactful. Because humans are naturally drawn to story, and data storytelling bridge the gap between the raw number and the real-world implications. It adds context, emotional, and relevance, ensuring that the data resonate with the audience and drive meaningful action. There are two techniques I mainly use to tell my story. Number one is storyboarding. I will first create the narrative flow that connect all the individual visuals together. Then I will strategically place these visuals to create a compelling story. Once I have my storyline created, I will focus on the design aspect of the dashboard, like setting color and tone and the overall visual aesthetics to boost user experience. If you are curious about how data storytelling is done with concrete example, check out the videos here. Now, as we wrap up our data analytics journey, remember this roadmap is more like a flexible guidebook rather than a strict rulebook. It's not a straight line. Think of it as a winding road with twists and turns. Each step you take isn't a one and done deal. You might find yourself skip some steps, or as your project evolves, new insights emerge, new requirements pop up. You might have to look back a few steps to add extra info. So stay agile, adapt to the situation, and let this roadmap be your trusty companion in the dynamic world of data analytics. Now that you know data analytic process inside out, the next question is, what are the tools that support you to perform these tasks? There are many. Well, too many that it can be overwhelmed, especially for beginner. So let's clear this up. Let's go back to the basics, the fundamental of data analytics. That is to get insight out of raw data to help business making informed decisions. So, which tool should you use? The answer is, we don't care. From my experience, the God-created tool Excel can handle pretty much all the tasks with a tiny bit of limitation. Okay, so without any further bias, let's get back to our topics and let me share with you my personal experience and the reason why I choose to learn these tools. So to be more objective this time, for each of the tools, we will apply the following questions. Why should we learn it? And how to learn it? Do let me know in the comment below what are your favorite tools and do you agree with my reasoning? For starter, I would definitely suggest you to make friends with Excel. Microsoft Excel doesn't need much of an introduction. It is widely used in many companies, small, medium-sized, and even large corporations. Its spreadsheet format design is so flexible, making it easy for basic data analysis and visualization. It is the go-to tool for less technical users and even mature data analysts. If you have no knowledge of Excel, it might take 1 or 2 weeks of dedicated learning. You can start with the basic, familiarize yourself with Excel's user interface, data entry, and basic formatting. Then basic formulas and functions to deal with number, text, date, and time. Aggregate functions to summarize data like sum, average, count, max, and min. Logical functions for complex decision making, and of course, some basic lookup function. The next step is to explore data analysis built-in feature, such as sorting and filtering to organize data, conditional formatting, data validation, and of course, pivot table, one of the most important features for data analysis. You can go to more advanced formulas and functions, advanced lookup function, then array formula. You can even program Excel to automate repetitive tasks using macro VBA. Excel also allowing you to visualize your data with graphs and charts. You can easily create single chart or dashboard in Excel, starting from basic to advanced as your Excel skills and knowledge grow. If you have Office 365, you can dive into advanced Power Excel features like Power Query for data transformation, Power Pivots and DAX for data modeling and advanced data analysis. As of September 2023, Microsoft announced that Python is available in Excel's in beta channel. My takes on this? Excel is on steroids, but more on Python later. Mastering Excel skill will give you a competitive advantage when seeking employment and will definitely give you a heads up in landing a job interviews and increase your chances of getting hired. Although Excel is a great tool for analytics, Excel does have its limitation when it comes to handle very big data or complex analysis. To do this, you need to understand data and how data is structured. So the next natural step for you to learn is structured query language, SQL. Much of the world's data is stored in databases. SQL, also pronounced as SQL, is a language that allows you to communicate with databases to query for information. SQL commands resemble natural language, make it easier to understand and remember. For example, this is the drink table. To see the content of the table, you can write a SQL query like this. Select everything from the drink table. Or select coffee from drinks where date is weekday. As you can see, the English-like comments making it more user-friendly for beginners compared to other programming languages. You can easily get familiar with the basics just within 2 to 3 weeks. Advanced level includes aggregate functions and group by, allowing you to summarize data and reduce data size. SQL operator like unions and joins allowing you to combine data from multiple tables. Plus, you can understand the relationship between the tables. These concepts might take some time to get acquainted with, but once you've mastered it, it opens door to a whole new data world. SQL is powerful for database querying and it is good for handling large datasets. Knowing SQL will enable you to work with different relational databases, including popular systems like SQL Server, MySQL, PostgreSQL, and so on. But there's a catch. SQL is powerful for querying data, but it's not ideal for complex statistical analysis and is certainly not a language for visualization. Personally, I use SQL mainly to querying data, summarize data, and build data model when my dataset contains hundreds of millions of records. When it comes to data visualization and storytelling, the top two choices you have are Power BI and Tableau. They are powerful BI tools for visual. They are both equally good and they can handle big data. I choose to learn Power BI as a natural next step for the following reasons. Most companies use Microsoft products like Excel, SharePoint, and Teams. Power BI integrates seamlessly with these applications, making it the obvious preferred choice. If you're just starting out, Power BI Desktop is available for free, and you can learn it easily without any extra cost. And this is not the case with Tableau. The learning curve for Power BI would be steep if this is the first tool that you learn, but for me, it's quite straightforward due to my previous experience with Excel and SQL. Let me explain. In Power BI, you will do mainly 4 steps. Data transformation using Power Query, data modeling using data model, data analysis using DAX, data analysis expression, and finally, data visualization in Power BI Canvas. This process is exactly the same as in Excel. Excel has Power Query. It also has Power Pivot, which allow you to build your data models and write DAX code for complex analysis or calculations. And of course, SQL knowledge is extremely helpful in this step to build the good data model, which as a result will optimize your DAX code even with big data. The only thing left to learn in Power BI is the visual aspects, which are another level compared to Excel. Also, the user-friendliness interface of Power BI and its similarity with Excel's interface make the transition to Power BI a lot easier. So for me, choosing Power BI is a no-brainer next step. To get through the beginning level, it will take you merely a week, and you can already create amazing visual at this level. While Power BI is fantastic for visualizing data and create stunning dashboards, sometimes you will want more advanced tools that provide deeper insights, complex statistical analysis, and customized solutions. With that in mind, let's talk about Python. Nope, not that one. This one. Python is by far the most requested skill when you want to land a job in advanced analytics. Python offers extensive libraries for data analysis such as Panda for data transformation, NumPy for scientific computing, Matplotlib and Seaborn for data visualization, making it a one-stop shop for data professionals. Plus, you can do more than just data analytics with Python. This includes web development, automation, artificial intelligence, etc. Python syntax is very easy to learn compared to other coding languages, thanks to the English-like command syntax, which make the code more intuitive and reduce the learning curve. Python uses indentation to define code blocks, which make the code visually clear and reduce confusion. Like learning any other coding languages, first you would need to familiarize yourself with the fundamental of Python programming, such as variables and data type, lists and dictionaries, loops, basic operation, and functions. When and only when you grasp the basic concept, then you can move on to explore essential libraries for data analysis, like NumPy and Panda for data manipulation, Matplotlib or Seaborn for data visualization. A piece of advice here is do not try to learn everything in one. If you are new to coding, focus on the process rather than the results. What I mean by this is instead of copy, paste the code from the internet or some AI tool, type the code yourself, debug your own code. And by doing so, you will remember the syntax much better and practice, practice, practice. Apply what you learned to a small project. Could be analyzing a new dataset or the one that you're already familiar with. This way, you will get to master your coding skill. Then you'll be able to read and understand other people's code or AI-generated codes and work further on it. Let's take a moment to connect the dots here. Remember, no matter which tool you use, don't forget the objective is to extract data and convert it into information for decision making. Choosing the right tool simply helps you to better perform data analytic tasks. You can use one tool or the combination of multiple tools to achieve the results you wanted. Here is what each tool can do and when it's best to use them. For small data sets, it's best to use Excel because it is quick, it offers flexible ways to analyze data, and best of all, it requires almost zero learning curve. Excel is a good tool to start playing around with data analytics. Of course, you can use other tools as well, but don't spend the 200% of the effort for just 10% of the results. When it comes to handling big data, while ensure the speed of your calculation, you can use other tools. Power Excel with functionality like Power Query and Power Pivot can also help you. But when you have a very big data, say more than 50 million records, it's best to consider working with Python or the combination of SQL and Power BI. For the minimum amount of technical knowledge, the combination of SQL and Power BI is your best choice. SQL for collecting, transform, and design data model. Power BI for analysis, visual, and storytelling. Python might be the best options to handle big data, perform complex analysis, and create customized charts. However, it's not intuitive as it requires some coding knowledge. Coding does take time to learn, but once you've mastered Python, you can steer your career to advanced analytics and other data science related fields. Are these absolute set of tools that you can learn? No. There are a lot more analytic tools such as Google Sheet, R, Tableau, SAP, Spark, and each tool focuses on a specific data analytics needs. Again, choosing the right tool depends on your data size and the purpose of your analysis. The four tools that I mentioned here are linked to my personal experience, their popularity, and their user-friendliness, and more importantly, the demand for their expertise. So you can't go wrong by picking any of these tools to learn. However, do not rush to learn all these tools in once. Take your time and master one tool first, because it is much easier to transfer the knowledge that you've learned from one tool to the other. If you don't have any technical background, start easy with Excel, then move on to improve your skills and knowledge with other advanced tools. Like I did, it worked out very well for me so far. Now on to the last point. By learning these processes and tools alone, will you be successful in data analytic career? Well, not quite. You will also need other important skills that steer your analysis on the correct path. You need to understand the industry or field that you are in. Knowing the industry context enables you to strategically think and ask relevant questions to scope your project and ensure that your analysis aligns with real-world needs of the business. Having a solid grasp of the industry and field that you are in enhance the ability to draw conclusions from the data that you're working with. For example, if you're a financial analyst, you might measure the health of the business with revenue, cost, margin, EBITDA. If you're a marketing analyst, you might dive into analyzing customer churn rate, NPS, CSAT. As you can see, without the industry knowledge, it's very difficult to make sense of the number. Other than domain knowledge, you also need to have some soft skills at hand. You need to be able to think critically, not afraid to raise questions, challenge the information as this might open a new direction for analysis. And above all, you need to be able to communicate to convey the insight to both technical and non-technical stakeholders. Tell your story to help them make data-driven decisions. And don't forget to connect with your colleague. Expand your network, whether it is with business colleague, fellow data analyst, data engineering data scientists, or with IT colleagues. Trust me, networking not only helps you to get your job done faster, but also unlock opportunity to grow your career. You might wonder why I mentioned these skills. Are these skills really that important? Well, let me tell you this. Soft skills are equally as important as technical skills. They will help you to advance your career. Let me give you an example. The questions you might encounter on your day-to-day tasks can be, can you refresh data for the latest month? Can you change the pie chart into column charts? Can you create a customer-centric dashboard to provide actionable insight for enhancing customer experience? Do you see the difference? These questions are more technical and it tells you exactly what to do without any context. If you just focus on the technical side, of course, you will be able to perform the task that's being asked. However, to advance to senior level, other skills are essentials to carry out the task. In this example, the questions is vague and it's up to you to figure out what are the next steps. You need to be a strategic thinker who can look beyond the number to understand the broader business context, asking critical questions to identify business problem, to formulate comprehensive proposal, as well as developing detailed action plans. Another crucial aspect for the roles is to connect with the right team to ensure effective solutions that drive meaningful impact. In essence, a senior data analyst combines technical expertise with strategic thinking, excellent communication skill, and a proactive approach to problem solving. And of course, a tiny detail that you might be very interested to know. With a high level of expertise, come a higher paycheck. Are you motivated? Keep analyzing. I trust that today's insight have resonated with you. And the key takeaway from here is it's not about the fancy tool that you are using. It's about grasping the fundamental of data analytics at the back of your hand and transforming raw data into actionable insight. Don't let the industry jargon overwhelm you. Cut through the noise. And also don't overwhelm yourself with learning from tools to tool without real-world experience. Take it step by step. Let your skill and experience grow over time. Remember, soft skills are also important. They are secret sauce to steer your analysis toward the finish line. I hope that this data analytic roadmap be your compass, guiding not only your daily work, but also your continuous learning and development plan. Do share with me the experience in the comment below. I'm all ears and excited to connect with you. If you want to see some of the techniques mentioned in this video applied in a project, check out the data analytic journey over here. In the series, I go over data analytic process step by step with practical case study. Downloadable workbooks are also available. Follow along and you'll be able to put the knowledge that you've learned today into practice. Don't forget to hit the like button and subscribe to my channel and share what you learned with others. Thank you for watching. See you next time.